What are the different types of horn antenna? Okay, so horn antennas are two types. One is rectangular horn antenna, the other one is circular horn antenna. When you will say that the horn antenna is rectangular, when you say that the horn antenna is rectangular wave. The rectangular horn antenna are fed with rectangular waves. Rectangular horn antennas are fed with rectangular waveguide. Fed with rectangular waveguide. Okay, while the circular horn antennas are fed with circular wave. Okay, so this is the broad classification of horn antenna. So horn antennas are classified into rectangular horn antennas or circular horn antennas. If the waveguide is rectangular in shape, we call it as rectangular horn antenna. If the waveguide is circular in shape, we call it as circular waveguide. Circular waveguide. And again coming to the classification of rectangular horn antenna. Again, coming to the classification of rectangular horn antenna. Rectangular horn antenna is again subdivided into two categories. One is called as pyramidal horn, and the other one is called as sectorial horn. Okay. So, what are the two classifications of horn antenna? Rectangular horn antenna and circular horn antenna. Again, coming to the rectangular horn antenna. Rectangular horn antenna is again divided into two types. One is pyramidal horn antenna and sectorial horn antenna. What is meant by this sectorial horn antenna? So, for example, if you take any waveguide, if you take any open end of mouth of waveguide, let us consider this is A, this is B. Okay. So this is A, this is B. Okay, I can flare in this direction or I can flare in this direction. Okay, so let us consider here the flaring in this 1, or I can done in 2. Okay, so in coming to the rectangular horn antenna, if the flaring is done only, performed only in one of the walls means either A or either at B. For example, if the flaring is done only along A direction, okay, not at B direction. Okay, not at B direction. So, or if the flaring is done at only at B direction, not at A direction, means if the flaring is performed only on one of the walls of the waveguide. If the flaring is performed only on the one of the walls of the waveguide, such type of waveguide is called as sectorial horn. Such type of waveguide is called as sectorial. And the other type is pyramidal. Okay, so pyramidal means if the flaring is done on both walls of the waveguide, the flaring is done on both walls of the waveguide, then we call the rectangular horn antenna as pyramidal. Is it clear? Okay, if the flaring is done only on one wall of the waveguide, then we call that the rectangular horn antenna as sectorial horn antenna. If the flaring is done in both directions, for example, in this here, if the flaring is done in both A side and B side, A side and B side, okay, both directions. Okay, such type of horn antenna is called as pyramidal. If the flaring is done only in one direction. So if you observe here, this is a rectangular waveguide. Here the flaring is done in this direction, and similarly the flaring is done in this direction also. Okay, so here flaring is done both sides, both directions, this direction and this direction. So this is called as pyramidal horn. Okay, let us come to the sectorial E plane. Here the flaring is done only in this direction. Here the flaring is done only in this direction. So this is called as sectorial E plane horn. Here, whereas here the flaring is done only in this direction. Okay, so here the flaring is done. We have opened in this mouth like this, that is E plane. If you open like this is H plane. This is H plane. Okay. So, what are the two classifications of rectangular horn antenna? Pyramidal and sectorial. Again, coming to the sectorial horn, it is divided into two things. One is E plane sectorial horn antenna. The other one is H plane sectorial horn antenna. One is E-plane sectorial horn antenna. The other one is H-plane sectorial horn antenna. So what is meant by the C-plane sectorial horn antenna? When one of the walls of the waveguide is played out in the direction of electrical field vector, if the flaring is done along the direction of electrical field vector, it is known as E-plane sectorial horn antenna. What is meant by H-plane? When the walls of the waveguide is played along the direction of magnetic field vector, then it is called as H-plane. Then it is called as H-plane. Then it is called as H-plane. So this is the broad brief definitions. Okay. So see here, these are sectorial horn antennas. Sectorial horn antennas. Here the flaring is done in this direction. Here the flaring is done in this direction. But here the flaring is done in this direction. Okay. So the flaring is done in this direction. So this is E-plane and this is H-plane. Okay. Okay, but whereas this is pyramidal, the flaring is done both here in this case. The flaring is done this both this direction as well as this direction. Okay. So in both direction the flaring is done. That's why it is called as pyramidal. Okay. So these are the broad classifications in rectangle. Okay, for example, here if you observe here the what is the waveguide here? The waveguide nature is circular. The waveguide nature is circular. Okay, so these are circular and this is biconical. Okay, so these are the classifications in circular waveguide horn antennas. Circular waveguide or circular waveguide horn antennas, because here the waveguide is circular. In the previous case, the waveguide is rectangular. Okay, so this is the broad classification. Okay, so rectangular, conical. Okay, so what are the two classifications in rectangular? Sectorial and pyramidal. Coming to the sectorial, what are the two classifications? E-plane and H-plane. Okay, so here the flaring is done both this side E-plane and H-plane. Okay, here the flaring is done only in E-plane. Here the flaring is done only in H-plane. Okay, so this is conical. Okay, so this is conical. Okay, so other one is called as exponentially taper. Exponentially taper. Okay, so what is the difference between exponential? In the previous way, for example, if you take this, in the previous one, here the waveguide is like this. Okay, the previous one, the waveguide. So what happened here? Whenever the signal is coming here, the some of the signal will struck here. Some of the signal will get struck here. So there is some ambiguity or there is some disturbance. But if the structure is like this, without any notch, the signal will go here like this without any disturbance. Okay, so such type of tapping or such type of construction is called as exponentially tapered pyramid. This is in the case of rectangular waveguide. This is in the case of circular waveguide. So we are going for exponentially tapered structures because here there will be no ruggedness. There will be no ruggedness. Whereas in the previous case, here there is a ruggedness and the signal is coming here. Some of the signal may okay, collision will take place and some disturbance will be take place. But here, if you see in this exponentially tapered, there is no chance of that ruggedness. There is no chance of ruggedness. Okay, so this is the